All right, welcome to this video, which is about, we are talking about numeric versus algebraic expressions. And now expressions are actually how you would say something versus how you would see something. So in algebra, in a lot of expressions, I just want to start off by introducing, or I guess reviewing, the term variable. So that's what I'm going to put in this blank. A variable is a symbol. It can be any symbol. It doesn't have to be a letter. It's usually a letter that represents the values of a variable quantity. So some examples of that could be x or y. Those are very common ones that you see a lot of places. You might see other ones. We're going to use other ones: a, b, c, um, even z maybe. Now I would avoid using some, for instance, like an s or an, so we'll say S and O because they look like a 5 sometimes, or they look like a 0. So we're going to not use those. But one thing that I like to point out is that it just has to be a symbol, and it's representing something, which is a number. But it can be any symbol. So if you wanted to use a smiley face, if you wanted to use a star, if you really wanted to use a sailboat, these are the ones that are used most commonly. You can, as long as it doesn't take away from what you're doing. Okay? So now to differentiate between numeric and algebraic expressions, we're going to be focusing more on the algebraic type because we are in algebra. But what I wanted to note here is that a numeric expression is just a phrase like 2 plus 2, and you could say it in words 2 plus 2, or 2 added to 2, or 2 more than 2. But they have numbers here and operations. And again, remember, operations are things like addition, subtraction, multiplication, and division. Those are our operations. So it has to have an operation and it has to have numbers. And you got yourself a numeric expression. On the other hand, an algebraic expression also has operations and it can have numbers, but in this phrase it must include variables, which is what we just talked about, variables. So an example would be 5 added to x. And I apologize for that plus sign. You could say it 5 plus x, or I mean x plus 5, sorry. But it just has to have some sort of variable and operation. So if we pull these down, I got a couple more examples. I'll just show you where they go. This one right here, sorry. This one right here, I'm going to grab this. This goes right here because it's just numbers and operations. This is just a number, and that makes it numeric. The rest of these all have, here's an x, here's an n, here's an x squared, and here is a symbol of star. They all have variables, so that makes them algebraic. All right, enough about that. Now, you're going to hear things being said. So, for instance, you might see 40 less than a number. And we're looking at the first one here. 40 less than a number. You want to know how to write that. We talked about some important words. Less than would be subtraction. So we're going to use subtraction here. But 40 less than a number could either be 40 minus a number, which would be x. We'll use x for this one. Or it could be x minus 40. And believe it or not, they are different. Because if you plug in 10 for x, you'll get, on the top one you'd get 30, and then on the bottom one you'd get negative 30. So they're different. The reason, I'm going to tell you right now that this one, the bottom one here, is correct. Top one is not. And the reason being is that if you look at 40 less than a number, so you have a number, which we'll just say is x up here. I'm going to model it here. And you want to take 40 away from that. So let's say this is 40. And we're going to get rid of that. 40 less than that number gets you left with this. Okay? So you're taking 40 away. So it'd be 40 minus, or x minus that 40. Similar story would be with addition. 32 more than a number, that's going to be addition. And the number we'll use x again. But we know there's addition. We can either do 32 plus x or x plus 32. Now in this instance, it wouldn't really matter because if you plug in anything for x, you'll get the same answer either way. But it really should be x plus 32 because you're saying 32 more than a number. So you already have that number. You don't know what it is, but you already have that x and you're adding 32 to it. Okay, so you're saying you have x and you're adding 32 to it to get you this grand total of not sure yet. Okay, so we don't know what that number is, but the phrase is x plus 32. And then the last one's the tricky one. It has two different operations. You have product, which is, of course, multiplication. And you have less than, which should be subtraction. Okay, so it's 10 less than a number. A product. So again, kind of like the top one here, you're taking 10 away. So it's going to be minus 10 at the end. You're taking 10 away from the product of 8 and a number. So I'll make that number y this time. So you can say 8y, that's product. 8 times y would be 8y. Taking 10 away from that because it's 10 less than 8y. And you are left with this expression. And that would be visualized similarly to the top, where you have 8y. You're taking 10 away from 8y. So you're starting with 8y. This whole thing is 8y. You're taking away 10. So we're going to cross that out, and you're left with whatever is in here. That's what you're left with. All right? And this is very important to know, being able to recognize the difference between different ways that things, numeric expressions or algebraic expressions, are actually spoken verbally and written with words, as opposed to just in the algebraic sense. Right? So that is talking about algebraic expressions and numeric expressions.